Yes.
So my talk is titled Threat Hunting with Endpoint Telemetry and AI-driven hunting. As the name says, we'll be focusing on how to perform threat hunting using endpoint data. Basically, I'll use Sysmon and a tool that I created named Garuda to demonstrate how you can use threat hunting. And also I'll show you how, when the tool was integrated with the LLM, how it can perform autonomous threat hunting. Okay. Now, before getting started, why this talk? As you all are aware, there is an increase in the number of cyber attacks targeting different sectors. Behind these attacks are adversaries, also called as attackers. They have different motives. The motive can be cyber espionage, political espionage, sabotage, intellectual property theft, espionage. Whatever may be the motive, they use malicious program, also known as malware, to infect their targets. Which means from a security standpoint, from an incident response standpoint, we need to understand how to analyze and hunt for threats. So this is not a topic on analysis, but this is more focused on threat hunting. Okay, so let's say the system is already compromised. How do you hunt for threats? Okay, that's the focus. Before I get started, let me introduce myself. My name is Monnappa. I'm an independent security researcher, mainly focused on trainings. I previously worked for Microsoft and Cisco as a threat hunter and an investigator, where I mainly focus on investigation of advanced cyber attacks. I'm also author of the book Learning Malware Analysis. And I'm also a member of Black Hat Review Board. I'm a review board member for Black Hat Asia, Black Hat US, Europe and India. I'm also co-founder of a cybersecurity research community known as SysInfo. Like you have this AI security community, we also have a community named SysInfo. I'll talk about that at the end. So in case if you're interested, you can visit this cysinfo.com, where we organize quarterly meets. Okay, and I'm also creator of a threat hunting framework called Garuda framework. Today we'll talk about that, and also Linux sandbox for analyzing Linux malware known as Limon. I'm also the winner of Volatility Plugin Contest 2016. In case if you're not familiar with Volatility is an advanced memory forensic framework. So I wrote a plugin in 2016 to detect anti-memory forensic tricks used by the attackers to bypass memory forensics. That won the contest in 2016. And I've presented and conducted trainings at various conferences like Black Hat, DEF CON, HATP and so on. We still do it. So that's about me. So let's get started. We'll start with what is threat hunting. Okay, so I will try not to assume that you already know. In case if you're, how many of you are familiar with endpoint data, SOC operations, threat hunting? Okay, that's pretty good. So hopefully you'll be able to understand this talk. And even if you're not, if you're new to it, if you focus, you'll be able to get it. Okay. What is threat hunting? Threat hunting is proactively hunting for hidden or undetected threats within your organization's network. Now, when it comes to threat hunting, you will make use of endpoint telemetry or threat intelligence feeds to look for any suspicious behavior within your network. Okay. Now, you can think of threat hunting. You can classify threat hunting into two types. Basically, IOC-based hunting and non-IOC-based hunting. In case of IOC-based hunting, you are hunting for known indicators. Like for example, you got threat intelligence feed where your, let's say, MD5 hash or a domain name or IP address or a URL and so on. So you are hunting for known indicators. It's more of a reactive approach. Okay, and there's non-IOC-based hunting where you are hunting for threats based on the attacker behavior and the TTPs. TTP stands for tactic, techniques, and procedures. Okay, so you are basically looking for the behavior of the attacker to hunt for unknown threats. This is more of a proactive approach. Okay. Now, whether you are doing IOC-based hunting or a non-IOC-based hunting, you are mostly hunting for malicious program. Why? Like I told you, attackers use malicious program to achieve their objectives. Like they may use malware to spy on your system or to take control of your system and attack other systems in your network and so on. So basically, when it comes to threat hunting, you are hunting for malicious programs. Okay. So, which means you need to understand how malware operates. Okay, that's a different topic altogether. That is more of a malware analysis topic. Anyway, we'll be talking about that in the next SysInfo meet. It's more of AI malware analysis. But at a high level, this is what malware does. When your system is infected with a malware, this is what it does. It interacts with the operating system in various ways. Now, it can spawn a new process, or it can drop a file, or it can access a registry key, or it can also communicate to the command and control server, basically to send system information or to download additional components and so on. Also, it can load a DLL to execute malicious code, or it can also inject code into a legitimate process to perform malicious action within the context of a legitimate process. Or very rare these days, malware may also install rootkits, kernel mode rootkits. Okay, so this is high level. Okay, till this point all okay?
Yes.
Okay. Again, feel free to ask any questions. If you want to just raise your hand and in between feel free to ask. I want to make it as interactive as possible. Okay. So with an understanding of what malware does, which means if you want to hunt for threats, you need visibility into all this activity, right? Because this is what malware does. You need visibility into this activity. For my project, what I did was I chose a tool called Sysmon. Okay, Sysmon is a free tool. Okay, it's from Microsoft. You can install Sysmon. When you install Sysmon, what it does is it installs a driver. It runs as a kernel driver service, and it logs operating system activity to event logs. Meaning, it logs various activity like process activity, network activity, registry activity, and so on to event logs. Okay, is it clear? Fine. Basically, it captures around 26 events. Okay, so let me quickly show that. If you go to this website here, you can download Sysmon from here. Just want to show you that it captures various events. Here you see, there is process creation event. Each event has an ID associated with it. Then you have network connection event, which has an event ID 3. You don't have to buy out all this, but just remember that it captures various events. Driver load, image load, create remote thread. Like that, then it captures around 26 events which are relevant for our investigation. Okay. Now, coming to how do you install Sysmon? Okay, before we get into the threat hunting, let me quickly give you an understanding of how to install Sysmon. Let me bring up the video. Okay, so I already downloaded Sysmon here. Okay, let me zoom for those who are not able to see there. Okay, so I've already downloaded Sysmon. You see here sysmon.exe is downloaded. Now to install Sysmon, what you do is, you will navigate to this path. That's what I'm doing, using command prompt. So I will zoom wherever you have an important concept to cover. You see here, what I'm doing is I'm navigating to the Sysmon folder, and to install Sysmon, you can supply with -i option. With -i option, when you supply it will install with default settings. When you say default, it will start capturing everything on the system, right? So that may not be what you want, because there are a lot of legitimate activity that gets captured. Unwanted noise, you will capture unwanted noise. Okay, you can install this way, but you will see that within seconds you will have thousands of events. Okay, but as an optionally, what you can do is you can also supply your configuration file. That's what I'm doing now. There's a configuration file you can supply. Basically, this configuration file defines the rules for Sysmon. It tells Sysmon what to log or what to ignore. Okay. Suppose you know certain activity is a legitimate activity, you don't want to see that. You don't want Sysmon to log that activity. So you can tell that, okay, you can define that in XML. If you look at the documentation, you will get to know Sysmon documentation. So it's a simple XML. You tell ignore this. Okay, is it fine? Yeah. So now I'll install it, Sysmon. This is how we install Sysmon. When you install Sysmon, what happens is, you will see that it installs a video playing. Yeah. Okay, so now what I'm doing is I'm installing Sysmon. When I install Sysmon, notice what happens is it installs Sysmon and it is running as a service. Now it is logging all the events. So where do you look at these events? Okay, so it's writing all the OS events to event logs. So what you can do is, once Sysmon is installed, you can open event viewer. That's what I'm doing. Okay, so when you open event viewer and you go to this path, application and service logs, Microsoft, Windows, under that you will see a log channel called Sysmon. Yeah, under that, notice it logs all the events. You see here, it is at this point, without doing much on the system, it logged various events already. Okay, you see there is a registry value set event which has an event ID of 13 and so on. Okay, there is file creation event, there is a process creation event and so on. Okay, is that clear so far?
Yes.
Okay, so now just to help you understand, I'll launch command prompt. And so when I launch command prompt, what happens is that Explorer launches command.exe, correct? Because whenever you double click an executable or right click and run as an administrator or whatever, it is Explorer, which is the default user shell, that will launch the command.exe, correct? So that event should be logged somewhere. So if you look at the event, you see here, I see there are two process creation events. Let's see which one is the one that we are looking for. If I click on this one, you see here, it says the image is open console. That's not the one. Parent image is svchost.exe. Okay, fine. So this is not the one. Maybe the other one. We'll see. Okay, let's look at the other one. And here you see that you see the image. That is child process is command.exe. Parent process is Explorer. Is it okay?
Yeah.
Fine. But you see the problem, I don't know, by now you got the problem. The problem is, if you are using for threat hunting, finding events like this is not efficient, right? So you need capability to correlate, filter and analyze the events more efficiently. Okay, that's where I wrote this tool called Garuda Framework, which basically takes the output from Sysmon and it gives you structured data. Okay, till this point all okay?
Yes.
Okay, so just be with me, we'll come to the threat hunting demo in some time. Okay, so that's what I mentioned. So now the point is, Sysmon logs various events. It's great, but the problem is, if you want to hunt for threats, you have to put some extra effort. You have to manually go look at it or use some filters and so on, but not efficient. Is it okay? So that's where I created this framework called Garuda Framework. This I released at DEF CON last year. So what is Garuda Framework? Garuda Framework is a PowerShell based framework which allows you to correlate, filter and investigate Sysmon events. Okay. So when you install Garuda, I'll show you how to install Garuda. When you install Garuda, it gives you various commandlets. In PowerShell, we call it commandlets. Okay. So think of it commands. Okay, let's keep it command. Okay. So it exposes various commandlets. Each command, using each commandlet, you can extract the Sysmon data. Okay. And not just that, it also gives you the advanced filtering capability. Meaning, it gives you the capability to filter on any of the attributes of an event. Meaning, for example, let's say you would retrieve process creation event. Process creation event can have various attributes like parent process, child process, parent process ID, child process ID, command line, etc., etc. So you can filter on any of those attributes of a particular event. Okay, is it fine?
Yes.
Okay, I'll show the demo. And then also it gives you the capability to perform time-based filtering using relative or absolute timestamp. Meaning, you can query the logs for the past 1 hour or 2 hours, last 24 hours, past 1 day, 2 days, etc. That is relative time filtering. Then absolute time filtering is you can query the logs, say that okay, I want logs from this day, this time to this day, this time. Is it okay?
Yeah.
So that's the absolute time stamp. Then that was about the filtering. Then there is also output. The output of the Sysmon is you can visualize in different formats. I called it views. Okay, there are different views in Sysmon. The idea is so that you can visualize the output in a more structured manner. Okay. So the different views, I'll talk about that. So now let me show you the Garuda. Give you a, yeah, you had a question? Yeah.
So is it visible in the SOC as well for an analyst? Once the events are logged and correlated
Mhm.
and filtered, so is that visibility going to the SOC as well?
SIM.
Yeah, the SIM, the SOC.
You can forward it to the SIM. At this point, no.
Okay.
But ultimately, because it is structured data, so you can still forward it to the SIM and also do whatever I show you now at the SIM level as well.
Okay.
Okay, is it okay?
Yeah.
Yeah, I'll show you how to install Garuda. Yeah, so here, so this is an open source project. Again, if you search for Garuda framework, you will be landing on my GitHub repository. Quickly, yeah. Okay, yeah, I guess internet is not working, but that's fine. But once you download, okay, here I've already downloaded it on my desktop. Okay, so the installation is pretty straightforward. Once you download, extract it, you'll see this folder. And inside that folder, there is a folder called Garuda. Okay, to install it is pretty straightforward. What you do is, I told you it's a PowerShell based framework, right? So you need to have PowerShell core installed, not the default PowerShell on Windows. the newer version of PowerShell. Okay, so the PowerShell that comes with Windows is 5 dot version something. Okay, but the newer version is 7 dot something. That's we call it PowerShell core. Okay, so you install PowerShell core, as you can see here, 7.5 dot version, and you run this command. Okay, this command is giving you the PowerShell module path. Again, don't worry much about that. Notice when I run this, it is giving me various paths here. You see here? It is okay? So all you have to do is copy that folder into one of this path. That's all is the installation. Is it okay so far? So I'm copying into this path, documents, PowerShell modules path, that folder. That's what I'm going to do in the video. Notice notice here, I'm in the documents folder, PowerShell. Under that, if this folder does not exist, you have to create it. Okay, and inside that you create a folder called modules, and inside that you drop that folder, Garuda folder. Okay, that's all is the installation. Is it okay? Any questions on that? Okay, pretty straightforward. And then once you install Garuda, okay, I told you it exposes various commandlets, right? So how do you look at the different commandlets in Garuda? This is the command. All Garuda commandlet starts with investigate keyword, so you will use this command. Get command, it's a PowerShell command. It will say, you're telling show me all the commands which starts with investigate verb. In PowerShell you have a verb dash noun naming convention. Okay, so but don't worry much about that. Remember, it starts with investigate. All the Garuda command, let's start with investigate verb. Okay. So when you run that command, it is giving you various Garuda commandlets. Each commandlet corresponds to a sysmon event. Okay, for example, investigate proc info will retrieve the process creation event logs. Okay, similarly, you have things like DNS query, network connections, image load, etc. etc. Is it okay?
Yes.
Fine. So depending on your objective, what event you want to retrieve, you can use appropriate commandlets. Till this point, all okay? Okay. How about at the back? You guys are able to see? Okay. Okay. Let me show you an example. Then we'll move on to the actual investigation. Once you are familiar with Garuda, you are ready to investigate. Okay. So first, what I'll do is I will run this commandlet investigate proc info. So what it should do without any arguments? What it should do? It should retrieve the process creation events. Correct. So that's what it does. By default, it will retrieve the logs for the past 15 minutes. Okay, if you don't give anything, that's the default. Okay, I'll show you how to retrieve for a certain time. But when I run investigate proc info without any arguments, it will retrieve the process creation events. Notice, as you can see here, it gave you a lot of data for the past 15 minutes. And the view that you're seeing, right, this view what you're seeing is called detailed view. Okay, meaning it gives you all the fields of the event. For example, here you see event ID 1. This is process creation event. Let me zoom that. Event ID 1, it's a process creation event. It is giving you all the attributes like which user launched it, process name, parent process name, command line, parent command line, etc. etc. Is it okay?
Yes.
This is detail view. The detail view contains all the fields. Okay. I'll come to the different views in some time. Now, you can also apply filters. Like I said, you see, I'm running investigate proc info. I'm using this parameter. Okay. Dash past minutes. Okay. Meaning I'm telling there is various arguments, parameters that you can pass, like past minutes, past days, and so on. Just type past and press tab, it will cycle through different options. Okay. So I'm telling retrieve the logs, process creation event logs for the past. Notice I'm just cycling now in the video. If I just press tab, it is cycling different options that starts with past. Okay. So I'm retrieving the logs for the past 15 minutes. You'll get the similar data. Okay. Is it okay so far? Fine. That's the time-based filtering. Remember I told you, you can filter based on the time. Instead of 15, if you gave it something else, it will retrieve the logs for that much time. Okay. Okay, now I told you, you can also filter on various attributes, correct? Meaning you can filter on, for example, if I want to filter on child process is command.exe, you can do that, okay? So let me show that. To do that, all you have to do is, You just have to know the name of the field. Let's say the process name is the name of the field which will represent the child process. I'll say dash process name command.exe. Okay. So I'm telling, so in short, what I'm telling is I'm telling retrieve the logs for the process creation events for the past 15 minutes where child process is command.exe. Is it okay? So now we should only get events where child process is command.exe. Right? So let me quickly run that. Yeah. You see that we got only one event, right? So earlier we had a lot of events, but this one we had only one event where the child process is command.exe and the parent process is explorer. Is it okay? Fine. Till this point, all okay? Just be with me for 2 more minutes and we'll cover the views and we'll move on. Okay. So now I'll show you the views. This is detailed view. Okay. This is too much of data. Okay. While investigating, you may not need all those data. So what you do is the same command, just supply the view parameter. Okay, so I'm showing one more example. Okay, you can combine the filters. Okay, I'm telling child process is command, parent process is explorer. Okay, so you can say, okay, show me all the events where child process is command.exe and parent is explorer, which should give the same data. And also, not just that, you can also use wildcards. You see, you don't need to provide a full process name, you just provide wildcard. So that will give the same data, you see, fine. Okay, then now changing the views, let's change the view. For now, the view is not, so there are different views. The first view that I want to talk about is timeline view. Okay, if you type view and press tab, it will cycle through different views. The first one is timeline view, which is the same data what you saw earlier, but much useful for investigation. Basically, this view shows all the events in a tabular format, sorted by timeline, sorted by time. Is it okay? Now you can quickly say that explorer.exe with the process, this guy, 4804, created this process command.exe with this process ID, and this is the command line arguments. Is it okay? Much faster to look at rather than going through all the all entire data. Is it okay so far? Any questions? Okay. So now also notice this timeline view does not give you all the data because it's a tabular data. I cannot cover everything in one screen. For example, notice the parent process path is not shown. Right? Sometimes you may need that. Right? So what do? So there is this one more view called timeline list view. Okay. Just change the view, do nothing, or the same command, just change the view to timeline list. You see here, I just did nothing, I just changed the view to timeline list. So, this data, it is giving you more details of this data, meaning it's telling me that the parent image is explorer, this is the path, you see, now it is giving you the full path, right? And it's command line, etc. Process creation event, it started command.exe and so on. So if you want the path of the parent process and additional details, you can run the timeline list view. Is it okay? Fine. Then there is one last view, that is summary view. So to help you understand that view, let me do one thing. Let me launch command.exe, command prompt, and let me start Notepad. And see that launch Notepad. And let's also start calculator, okay? That launch calculator. So what happened? So what should have happened? This instance of command.exe should have launched 2 processes, right? One is Notepad, other one is calculator. Is that okay? So what I want to show you is the summary view. So now if I retrieve the process creation events for the past 5 minutes, where parent process name is command.exe, okay, you guys with me so far? And view is timeline. For now, I'll just show you when I show the view. So what happened is, we know that the same instance of command.exe, process ID 9052, started Notepad, it also started calculator, correct? Now, let's say the same instance, okay, is starting 100 process. Okay, so you may want a quick summary of everything, every process this this command.exe started, right? So that's where the summary view is useful. Okay, for example, let me change the view to summary. For example, this is useful when you want to look at the DLL stored by a process and so on. Okay, so let me change the view to change from the timeline view to summary view. So notice this is giving you a quick summary of everything this particular process did. Okay, 9052. Is it okay? So it's telling this process started these two processes. But imagine this process loaded 100 DLLs. Instead of looking at this process loaded kernel32.dll, this process loaded also loaded ADV, PA32.dll, etc., you can say, show me all the DLLs loaded by this process. Okay, it depends on what you're investigating. That's where the views are useful. Okay, is it fine? Till this point, okay? So if you understood till this point, now from now on, it will be interesting because now we will use Garuda to hunt for threads. Any questions before we move on? All good? Okay, cool. So now what we'll do is,
I have a question.
Yeah.
Is this framework being used by any of the OEMs?
any of the,
OEMs, original equipment manufacturers. Like for example,
I don't know who is using, but maybe they may be using, I'm not sure. It's an open source project, so maybe they may be using it.
okay,
Yeah, I know few people reached out and they said they'll use it, but how they are using, I'm not sure.
okay.
Yeah. Okay, now let's get back to threat hunting. Okay. Now to keep it realistic, let's do this. Okay, so we will investigate this attack. This is a scenario. While monitoring for a security alert, your security device alerts on a suspicious communication from this IP to this domain. So this is a malicious domain. Okay. You are asked to investigate, determine the root cause. Okay. Is a scenario okay? Fine. So we'll start investigating. This is a malware called Keybase, which was used in a targeted attack. Oops. Which targeted our Indian Navy submarine manufacturer. So let's see. Okay. So first I'm listing all the available command threads, which you already know, right? Now, so which command thread do you think we should start? We'll make it interactive. What do you think we should? Where do we start?
IP. IP or domain.
Which one?
Network, DNS network.
So we start with DNS query. Why? Because we know there is a communication to a domain. Correct? If there is a communication to a domain, that means it has to resolve the domain. Correct? So let's see. Let's use investigate DNS query info command thread. Okay? Let's do that. That's what I'm going to do. I'm going to run investigate DNS query info. I'm retrieving the logs for the past 45 minutes. And there is a field which I'll show you in that event called query name. That is where it will show which domain it queried. Is it okay? So what I'm doing is I'm saying show me. Notice I'm using wildcard. I'm not giving the full domain. Remember the domain name? Some bemchem whatever ac.id. something. So I'm telling show me retrieve the DNS query logs for the past 45 minutes where this field contains this. Is it okay? So if there was a DNS query to this, we should get some hits. As you can see here, this is event ID 22, which is DNS query event. And you see the query name field has this domain. So again, this is detailed view. You can change the view, like I said, change the view to timeline. Notice I just changed the view to timeline. The same command as before, but I changed the view to timeline. Now it's telling me that PowerShell with a process ID 3368 made a DNS query to this the malicious domain that was detected by our security device, and it resolved to this IP 192.255.5.201. Is it okay? Fine. Okay. Now PowerShell is a legitimate process, correct? We'll come to that. But I also want to see it resolve the domain to this IP. Did it make any network connection? Because after resolving, maybe it may be connecting to a HTTP, it may connect HTTPS or something else, right? So you may want to look at the network connection. So what plugin, what command line do you think? I mean, you don't need to know the exact name, but what do we look for?
Protocol info.
Yeah, network info, right? So you may want to check was there a network connection made by PowerShell to this IP? Is it okay? So that's what I'm doing now. So there is this network connections command let. I'm telling retrieve the logs for the past 45 minutes. Where process ID, I think I'm using process ID, yeah, 3368 PowerShell. Show me all the network connections made by PowerShell. Is it okay? Fine. This is detailed view. I normally use timeline view. So you see, this one is telling you that PowerShell, the same PowerShell which made a DNS query, because it means is also connecting to this destination IP on port 80. So what does it tell you? Yeah, it tells you that PowerShell made an HTTP connection to that particular domain, right? Okay, now the question is, why did PowerShell make this connection? PowerShell is a legitimate operating system binary. It should not do malicious things, okay? So what do you think we should look for? Child process, but let's say if I ask you to if you want to make PowerShell do malicious things, what do you do? One is script. Second, you can pass an argument, command line argument to PowerShell in a way that it can do malicious things, right? So you may want to inspect the two things here. One is, why is PowerShell doing? Two questions. One is, why is PowerShell making malicious communication? Second thing, how it is, I mean, what is the command line arguments? Okay, so these two things, how do we do it? You can take any approach. What I will do is, I will see who created PowerShell. Okay, so how can I do that? Any idea? Which command?
Parent.
Yeah, the process creation event. Okay, so that's what I'm going to do. We will retrieve the process creation events. Investigate process info. Yeah. So what I'm doing is, I'm telling retrieve the process creation events for the past 45 minutes, where child process is, in a process creation event, you have a parent process, you have a child process. Okay, I'm telling where the child process is 3368, which is PowerShell, correct? So in this case, if you look at the event, you see command.exe started PowerShell, okay, and PowerShell was passed with this command line argument, which is here. PowerShell was, so you will have to visualize, okay, command.exe started PowerShell. PowerShell was passed with this command line argument. What is it doing? It is downloading a file from this command and control domain, which is okilo.exe, dropping it to the hard disk as doc6.exe. Is it okay? So something happened on the system because of which command.exe invoked PowerShell. It was asked to download this binary, drop it onto the disk. Okay? Because of which PowerShell made a DNS query, because of which it made a HTTP connection on port 80. Is it okay so far? Now the question is, why did command.exe launch PowerShell? Command.exe is also a legitimate binary, correct? So we call it living off the land attack, right? So what do we think we should do? We will probably look at
process info of command.
Yeah, we'll see who started command.exe. Okay, that's what I'm trying to check. I'm reading the process creation events. I'm telling who started, I'm asking who started PowerShell, command.exe. Okay, so you see that command.exe was started by Excel. Okay, we'll come to that. But also what's interesting is command.exe was passed with this command line arguments. Is it okay? That means command.exe was asked to invoke PowerShell, which we saw, for what? To download this binary, drop it to the disk. Is it okay? And there is also an AND command, AND operator here, which means another command. Okay? A reg utility, which is used to access registry key, was used to hijack the registry here basically and associated with the dropped file. Basically this was a registry hijack technique. Okay, basically it's associating MSC file with this. Okay, when you launch event viewer, what happens? This file there is a snapshot called mmc.exe which will launch an eventviewer.msc file. Okay, so basically it is associating that guy with this guy, and notice he is launching event viewer so that this binary gets executed. Again, don't worry much about that. It was a registry hijack technique using which anytime a MSC file is launched, this binary will get executed. Is it okay? Okay, that means command.exe was asked to invoke PowerShell. Command.exe was asked to invoke reg utility to perform the registry hijack. Command.exe was asked to invoke event viewer. Okay. Command.exe was also asked to ping. This is a way of sleeping for 15 seconds. Is it okay? Fine. Finally, command.exe launches the dropped binary. All good so far? Fine. So now we can also verify. See, command.exe was passed with all these things. But did command.exe launch PowerShell? Did command.exe launch reg utility? Did command.exe launch event viewer? This. Okay. So how can I do that? How can I check? Any idea? Send process creation event where parent process is command.exe. Okay. So that should tell you all the process that command.exe started. You see here we saw command line arguments was passed. Here this confirms that command.exe started PowerShell, which we already know, to download that binary, drop it to the disk as docs6.exe, and command.exe also starting reg utility, command.exe also starting event viewer ping, and finally the drop binary. Is it okay? All good so far? Okay, done. Okay, that we verified. Now the question is, why did Excel start command.exe? We are going reverse. Okay. I'll show you a faster method, but I wanted to show you manually how it's done. Okay. So what did we see? We saw PowerShell started by command.exe, command.exe started by Excel, right? Now the question, Excel is also a legitimate binary, correct?
Maybe a macro or a file.
So why did Excel launch command.exe, correct? That's the next question you may want to answer. So Excel's process ID is 8364. Let's see who started Excel. Okay, by the way, I'm just showing the summary view here. Notice here, the same command.exe started all this process, right? So when I run summary view, it's showing the same thing. Okay, so I'll just forward that part. So now we'll focus on Excel. Who started Excel? I'll change the process ID to Excel's process ID. Okay, this is interesting. You see, Outlook.exe started Excel. Okay, so what do you think happened? Yeah, someone received an email containing an Excel sheet, okay, which probably opened. As a result of opening that, macro got executed, which invoked command.exe, which in turn invoked PowerShell to download a binary, drop it to the disk, and then command.exe invokes the drop binary. Okay, how do I find out which Excel? Any idea?
With the file?
No,
Doc.
file name I don't know, so that's what I want to find out. What do you think I should do now? You can look at the command line arguments passed to Excel. Okay, you see? Right, so it tells you that someone received an email which contained an Excel sheet named enquiry.xls, which they opened, right? And as a result of opening this Excel, macro got executed, which in turn invoked command.exe, which in turn invoked PowerShell to download a binary, drop it to disk, and then execute the binary. Is it okay? So this was a manual approach. Okay. Now I also created another commandlet called investigate process tree. Okay. So whatever we did was manual. I wanted to show you how it works. Okay. So what this does is this commandlet, you can give any process in that chain, in that attack chain. It will give you the tree structure. For example, I am giving the process ID of Excel 8364. I'm telling, show me the tree structure of Excel. So this is just showing you one level. It is telling me that Outlook started Excel, Seeing it's telling me Outlook started Excel, but this is not very interesting. So there is another parameter if you pass to that command line. Notice I'm just passing a parameter called include tree. Okay, you guys with me? When I do that, it will give me the entire tree structure. The one that is highlighted in the pink is the one that we searched for, correct? And you see that Explorer started Outlook, Outlook started Excel, right? Outlook started Excel, and Outlook started Excel, and you see Excel opened this enquiry.txls. As a result, it started command.exe, and you see the command line arguments passed to command.exe. It was asked to invoke PowerShell and all those things that we saw. As a result, notice command.exe starts PowerShell, Reg utility, event viewer, ping doc6.exe. Okay. You see that it gave you the entire attack chain. Okay. Any questions? Fine. This is a semi-automated approach. Okay. So I thought, write a plugin which will give you the answers quickly. Okay. So far all okay? Fine. So that was the first attack. So we now know that on the system, user received an email containing an Excel sheet which you open and all these things happen. Okay. Now what I did was, now what does it have to do with AI based hunting? Okay. That's where it gets interesting. So what I did was, that's the next demo. The same attack, what we'll do is, so the tool that I created, Garuda Threat Hunting Framework, was not meant to be a AI threat hunting tool. Okay, it was a manual threat hunting tool. As you saw, you can use it for manual threat hunting. But what I wanted to see is, what if you give this tool access to the LLM? Okay, what does it do? So that's what I did. So I gave Garuda access to the LLM. I created an MCP server, which gave access to the Garuda, right? And I wanted to see if AI can perform autonomous hunting, because when it comes to AI, if you ask what is the weather today, right? The LLM will not have the answer. What is the weather today? That is because it is a trained model. It has a cutoff date, where, right? Now, but you might say it gives me the weather. How does it do? Because it uses a tool, right? Either it uses a search tool or a weather tool to get the latest data and give you the weather, which means you give the context through the tool to the LLM so that it does something meaningful, correct? So if you just ask an LLM to go and hunt for threats, it won't be able to do it. So you need context. The context is the tool that I gave access. Using the tool, I'm giving the context to the LLM. Is it okay? So that's the logic. Now, we'll get to the demo now. Okay, so same attack, we'll see what LLM does. Okay, so now, okay, so I'm using a slightly old video. I'm using Claude Sonnet 4. Okay, now I'm going to give a prompt. But before I give the prompt, before I ask AI application to hunt for threats, okay, also notice I've created this MCP server, Garuda Threat Hunting MCP server, and various tools are given access to the LLM. Is it okay? Fine. Now, before I ask AI application to hunt for threats, I want to show you the environment where we will execute the malware sample. Okay. So this is the Windows virtual environment where I'm going to execute that sample. Okay. And also another thing that I'm doing is, again, don't worry much about it if you're not familiar with malware analysis. I'm simulating various services on a Linux VM. Okay, why? Because I'm not allowing the malware to communicate to the actual command and control server. At the same time, when the malware requests for any service, this inet sim gives appropriate response back to the malware. Is it okay? Is it fine? Okay, so this is the environment. Again, even if you don't understand, leave it, forget it, don't worry about that. Okay, so then we will go to the Windows environment, and I'm also running Wireshark on my Linux VM, just so that I can capture the traffic generated by the malware, okay, before executing the sample. Now I'm going to copy the malware sample, which is that email, okay, in the Windows, inside the Windows machine. We will open that email. By the way, this was the, like I said, this was the, this was a targeted attack against our submarine manufacturer, which was called Musgon Dock. There's a full analysis on the Sysinfo website. I had done a full analysis in case if you're interested. Okay. Basically, they targeted. It's a Musgon Dock is a shipbuilder. They call it the shipbuilder of the nation. They build warship and submarines for Indian Navy. Okay. So the timing of the attack also was interesting. You can refer to the blog post. Okay. So, but this is the sample that was used. So you open that email, and you see there is an Excel sheet called inquiry.xls, right? If you open that, notice there is a macro. It says there enable macro. Okay, this is the only thing that is stopping a user from getting infected. When you click on the enable macro, it will execute the macro, drop a sample called key-based malware, okay? So which has the capability of take desktop screenshots and so on. Okay, so that's what they were doing. They were trying to probably steal blueprints and whatever, design documents from this warship manufacturer, okay? So enable the content, it executes the macro, and notice as soon as I execute that macro, it made a connection to that command and control domain. That is whatever we saw earlier, the webcam.undip.ac.id, and it is communicating on port 80 HTTP. And if you look at the TCP stream, you see this is what it did. It is trying to download this okilo.exe from this command control domain, and because I'm running inetsim saw it is downloading an executable file, it gave a dummy executable back. Is it okay? You guys with me so far? Okay, now, but in reality it will download the actual malware. Okay, so now as you can see here, or here inside the Windows virtual machine, it gave you this pop-up. This is as a result of executing that binary given by inetsim. Okay, is it till this point okay? And notice there is doc6.exe running. In this case, that doc6.exe is nothing but doc6.exe is nothing but our inetsim binary. Is it okay? All good? Fine. So this you know. Now we will ask AI application to hunt for threats. Okay. Now this is the prompt that I'm giving. Okay. I'm giving a prompt. If you read the prompt carefully, you will see nowhere I'm giving any starting point to the LLM. Okay, I'm not telling, okay, there was a communication to this domain or whatever. Okay. So what I wanted to check is, can AI parse, go through all the logs and identify the malicious activity? Okay. So that's what I'm doing. I'm telling, connect to that system where I infected the system, and investigate the attack, and then get these details: attack summary, execution flow, MITRE techniques, indicators of the compromise, and also give me a code for the dot file, okay, and the PDF report. Okay, I'll show you what that dot file is. Is okay so far? Prompt okay? So this is what I'm going to give to the LLM, and this is what I'm giving. Let's ask it to hunt for threats. Now what you will see is, it is giving you this pop-up, meaning whenever you see this pop-up, it means that it is asking you permission to execute a tool that you give. Okay, that means it's telling me in your Garuda threat hunting MCP server there is a tool called Connect Windows. I'm going to use the first, it has to connect to that Windows, right? So it's telling I'm going to connect to the Windows. Okay, you can either allow always, but it's always a good idea to see what it does. So I normally allow once to see what it's doing. It's always better to keep an eye on what it does, right? So allow once. Okay, so now what it is going to do is, it is going to connect to that Windows machine. Okay, and then notice, you see the response says successfully connected. Okay, Garuda framework detected and ready. Okay, so let's see. And it's telling, okay, now I'm going to run this hunt with Garuda tool. Okay, so allow once. Again, now you will see multiple tool calls, like how we had to run multiple tools, right? Multiple commands. This the AI also have to get all the data. It has to dig deeper. It has to make multiple tool calls. It says, I can see a suspicious activity. There's a clear malicious behavior involving exec. Okay, if you read that, it said it found something related to Excel. Okay, so now let's allow it. Maybe it will dig deeper. Notice it says Excel executing PowerShell. If you read through that, okay, let me dig deeper into. Okay, now it is digging deep into the. It is making multiple tool calls, getting the data, trying to correlate all the information. Okay, whatever we did manually. So now, yeah. So let's allow it to run. Maybe slightly forward a bit. Okay. So you get the point. So it is running tools, making tool calls. Okay, it says, perfect. Now I have complete picture of the sophisticated malware attack. Let me create a comprehensive threat hunting report. Okay, I think it did all this investigation by running various tools. Now let's see what it found. Okay, so it is going to generate a PDF report. Notice on the right hand side it is creating the report. Anyway, we'll download and see. Okay, so as you can see, it already detected inquiry.xls, blah blah blah. We'll come to that. Okay, I'll just forward. I'll anyway download that report and show it to you. We'll see what it detected. Okay, then in addition to that, it also gave me a dot code. Okay, so because I asked for a dot code, wait, that will give using which you can visualize the attack. This is the code. I'll copy that to a dot file. I'll tell you why. Okay, so I'm going to copy, save it as I think report dot. Okay. Now I will download this report. Okay, we'll see what it did. We want to see whether it was able to hunt for threats automatically. Okay, so export, save as PDF. Okay, so I'll save it as output.pdf. Now you open the report. First we'll open the report. Okay, so if you read the report, it says, let's quickly read the report. It's a sophisticated malware attack has been identified, targeting system through a malicious Excel attachment, which is correct. Attack chain involves macro-enabled malware delivery, PowerShell execution, malware download, persistence backup. Okay, that's kind of correct. And you see here, it detected which was the Excel involved, inquiry.xls, and notice it says this is the key findings. Okay, malicious Excel executed via Outlook. Okay, that is correct. PowerShell used to download malware doc6.exe, if you recall. Okay, and also it identified the registry hijack technique. Remember? Okay, and then USC bypass. That was a USC bypass technique as well. And then we'll see. And you see, this is the execution flow. Here, the bottom one here. This mouse cursor where I'm pointing. Stage 1 is initial infection, where Excel attachment was downloaded. Okay, Excel launched this malicious document. Fine. Then we have the macro execution, which is a stage 2. Excel spawns command.exe, which we know, and command.exe launched PowerShell. That is also shown here. Okay. The third stage is PowerShell downloads malware from this. Notice the domain. It automatically identified the command and control domain here, stage 3. Okay. Here, this one. Oops. Yeah, here. It identified the thing. And also HTTP connection to download okilo.exe. If you recall, it downloaded okilo, dropped it as doc6.exe. Correct? Okay. And also this registry persistence. It automatically identified that. Okay. And what's interesting is, it automatically mapped the events to the MITRE techniques. Okay, so remember the Garuda framework did not have any patterns to match the events to the MITRE technique. But notice, because we gave proper context to the LLM was able to automatically map the events to the MITRE techniques. We did not write any signatures or patterns and so on, right? So normally what we used to do in Microsoft or whatever, we used to write patterns to hunt for threats earlier. But here, notice, without writing any patterns, no signatures, nothing, it automatically mapped the events to the MITRE framework. Okay, that's pretty interesting. And then notice it also extracted the indicators of the compromise, right? The network indicators, file indicators, and so on. Okay. And let's look at the dot format which it created. This is just to visualize the entire attack chain. Okay. So notice the user received an email. containing an Excel. Excel was opened by Excel process, which in turn started command.exe. That's what it's giving a visual representation. Then command.exe launched PowerShell to download the malware, drop it to disk, and then command.exe performs the execution. Is it okay? So that's just a visual representation of the attack chain. So any questions so far? All good? So that's how AI was able to perform autonomous hunting. Okay. So now I thought, okay, this is one-off case. I could not believe that AI could do all these things. Okay. But then, okay. So let's look at the second demo. Okay. So you guys ready? All okay. So slightly different one. Again, one more living off the land attack. So let's take this scenario. Your security device alerts on a malware communication from that IP to this domain. Okay. You are asked to investigate this alert, determine the root cause. Okay, all good? So you start with what you know normally. So what you know is there is a communication to this domain, which is this one, K1GM, whatever. Okay, so let's bring up the demo. So we'll start with the manual. Okay, because you need to understand how to do it manually. Like I said, in this case, only maybe 1% was AI component. Okay, the rest all is mostly manual component. You need to understand your domain so that you know how to give the data to LLM, right? So it's not, don't assume that AI will do the things for you. Okay, so you have to give the proper context. To give the proper context, you need to understand the domain. Okay, so let's do that. So let's start by investigating the DNS query. Okay, so we'll start by investigating DNS query. So we look for that domain. Okay, that's what I did now. You see, I'm retrieving the DNS query logs, looking for that domain, K1GS, whatever. Okay, let's look at the timeline. So this one is interesting. As you can see here, curl.txt made a query, DNS query to this domain, which resolved to this IP address 146. Okay, you guys with me so far? But there's nothing called curl on Windows, right? So there's nothing called curl.txt on Windows. Now your question is, what is this curl? Okay, let's see. We may want to check who created this curl.txt, right? Oh, okay. Before that, we saw there's DNS query. We may want to check whether it made a network connection to that IP address, right? So that's what I'm doing. I'm checking. Now this time notice, I'm telling show me the network connection to this destination IP. Okay? You guys with me so far? All good? Okay. So there are two events, okay? If I look at the timeline, you see that same curl.txt made a network connection to this IP on port 80, again port 80. So it tells you that the curl.txt made a HTTP communication. Okay? Now the question is, what is curl.txt? So what I'll do is, I'll check who created curl. I'll retrieve the process creation events. Where process ID is curl.txt, that is 9164. I'm telling who created curl. As you can see here, command.txt created curl. Is it okay? But notice the arguments passed to curl. Curl was asked to download a PHP file, drop it to disk. It may not be PHP, it may be anything. Okay? Drop it to disk. So basically this curl is acting like a browser. You guys with me? Fine? It's acting like a browser. Okay. Now one more thing you may want to check is, did curl drop this file onto the disk? How do you think we should proceed? How do I check? Did curl drop a file? What activity will give me that? Huh? Yeah, file system activity. Okay. So we'll see whether curl dropped this file or not. Okay. Did it create this file? The drop.tmp file. Okay. Just verifying. Okay. So here I'm using this file create commandlet. Here you see this curl.exe created various files. One of them is this drop.tmp. Is it okay? You guys with me? So that confirms that, okay, curl is acting like a browser. It is downloading some what looks like a PHP content, drop it onto the disk. Okay, so that is drop.tmp. We don't know what drop.tmp is. We'll come to that. Okay. So now, okay, then the question, okay, we know that command.exe started curl. We don't know what this curl is. Okay, it is acting like a browser. But then let's see who started command.exe. Okay, fine. That is 8324 because command.exe is also a legitimate process. It is not supposed to do malicious activity. So it shows that winword.exe started command.exe. What does it tell you? What does it tell you?
Document file.
Yeah, so there's a document file which was opened. As a result, it invoked command.exe. Now, what's interesting is this one. Command line arguments passed to command.exe. Command.exe was asked to set a variable u to util.exe. You guys okay so far? Okay, and notice it is copying this system32 cert u will be replaced. So what does it become? Certutil.exe. Okay, that is copied as curl.exe, which means the curl.exe that you saw is a legitimate binary on the Windows operating system. There is a binary called certutil.exe. Okay, if you go to attack wiki and then search for certutil, you can use certutil to do certain things. Okay, so here, why do you think attackers use this approach, variable substitution? Any idea? Yeah, so basically, if you are looking for pattern for certutil.exe, right? If you are looking for pattern, you will not find that pattern because now it is during runtime it is basically doing a variable substitution and then copying it as curl. Is it okay? Fine. So now you know the curl is nothing but certutil.exe. Okay? And then what it's doing is it is asking curl, which is certutil, to download that PHP, drop it onto the disk, which we saw, correct? You guys with me so far? Just be with me. And what do you think this is doing? This one. Here. So what file do you think this is? Drop.tmp. Any idea? Yeah. Correct. So basically, this is again a legitimate utility on Windows operating system using which you can register a DLL. Why do you want to register DLL? To execute the code within the DLL. Is it okay? If you remember, this was downloaded earlier. And DLL cannot run on its own. You cannot double click a DLL and run. It has to be loaded by some process. In this case, regsvr32.exe is registering this DLL so that regsvr32.exe will load the DLL, call a function called DLL registry server in the DLL and execute the malicious code. Is it okay? Fine. So this tells me that malware downloaded the binary, loading the DLL to execute the malicious code. Okay. Now the next question is, why did Winword do this? Okay. To do that, what I can do is okay. What I did was I just ran the timeline list view. Okay, the same command. I just replaced the timeline with timeline list just to show you. This is another way to look at it. Okay, just to show you that Winword. You see now it is showing the full path of Winword and the command line passed to Winword. Okay, so just to show you that this is the document that was opened. As a result, macro was executed, which in turn started command.exe, did a variable substitution, copied certutil as curl.exe, downloaded a DLL. To load a DLL, it made use of regsvr32.exe. Is it okay? We are going reverse. Okay, so that's what happened on the system. Now, what am I doing now? Okay, so here I'm checking, did command.exe 8324 is command.exe. What all process created by command.exe? Just to show you that command.exe created curl, which downloaded this binary, correct? Command.exe also should have created registrar32.exe, correct? Earlier, if you see, to load a DLL, correct? That's what it's doing. Basically, it is using the 32-bit version of registrar30.exe. syswow 64 means, even though it says 64, it is a 32-bit binary. On Windows, you have, on 64-bit Windows, you have 64-bit version of all the components in system32 directory. Also, 32-bit components residing in this directory. Is it okay? Fine. So it is using registrar30.exe, it's a 32-bit to load a DLL. Now what I'm going to do is, I'm going to see what this registrar32.exe is doing. Okay, 6848. Okay, just to show you something. As you can see here, the 32-bit version of registrar32.exe, which is this thing, 6848, created a 64-bit version of registrar32.exe to load this DLL. So it tells me that the DLL was a 64-bit DLL, okay? A 32-bit process cannot load a 64-bit DLL, right? That means this is a 32-bit. So it launched a 64-bit version to load the DLL. Is it okay? Now, to check whether registrar32.exe executes a code within the DLL, what I did was, I created a dummy DLL, okay? I configured initsim to give the dummy DLL back to registrar30.exe. If the code is executed within the DLL, it will launch calculator. You guys with me? Okay, so now, which means if this attack succeeded, this registrar32.exe should invoke calculator. You guys with me? I know it's getting complex, but okay. Twist and turns. Okay, so that's how it is. Okay, so we'll do this. We'll see, did this registrar32.exe create calculator? Okay, that's what I'm checking. Oh, by the way, okay, so another thing that I'm checking is, okay, did this instance of registrar32.exe load this DLL? What do you think I should check to confirm? Yeah. So that's what I'm checking. Show me all the modules that are loaded by this instance of registrar32.exe. Is it okay? If it loaded this DLL or not, that's what I'm checking. As you can see here, this registrar32.exe image load event loaded a DLL, and it's an unsigned DLL. Okay, fine. That confirms registrar32.exe loaded the DLL. Now, as a result of loading the DLL, did it execute the code within the DLL? How do I confirm? I told you this DLL invokes calculator. Okay, so if you check the process created by that instance of registrar32.exe, if it invoked calculator, which means this attack was successful, right? So 3060 process, I'm checking, show me the process created by registrar32.exe. As you can see, it created calculator. So that tells you that user opened the document, macro got executed, which invoked command.exe, which copied certutil as curl, downloaded the DLL. To execute the code within the DLL, it makes use of registrar32.exe. Is it okay? Fine. Again, this was a manual approach. The semi-automated approach is the process tree plugin, which I'll quickly show you. With that include tree option. As you can see, when I run that plugin, you see Explorer created WinWord opened d.doc. As a result of opening that, it invoked command.exe. Command.exe did all these things, copy curl, whatever. And then notice it invoked curl. Why? To download that binary, drop it to disk. Then it invoked registrar32.exe, which is a 32-bit version, which invokes 64-bit version to load this DLL. Is it okay? Drop.tmp. And as a result of loading the DLL, it invoked calculator. Is that clear? Fine. So this was a semi-automated approach. Again, the last demo. Again, what about the AI? Does AI detect all this? Let's see. Okay, the last demo, I had a few more demo, but I think I don't have time. Okay, so But yeah, so let's look at the same thing. Okay, I'll just quickly cover it and finish it off. Okay, same, you already know the drill. Okay, so we give the same, what you call, prompt. We ask it to hunt for threads. Okay, and it will say I'll connect to the host, whatever. It will launch all those tools. As you can see, it's successfully connected. Again, it's all doing autonomous hunting. Okay, I can see a potential malicious activity. Okay. Okay, DNS query. It found some DNS query. It is querying that. Okay. It is digging deep using that as a starting point. And then, okay, it also found curl.txt, something to do. It is using those filters. Okay, let's see. Curl.txt. Okay, cool. So then I can just forward that part. Okay, just to show you that. Okay, it makes multiple tool calls. Finally, what it does is, okay, so I think it detected the attack. It is generating a report. We'll look at that quickly. Let it generate the report. I will copy the report again. Same thing. Forward the part. Okay, I'll copy the dot file as well as the report. Let's download the report. See what it detected. Okay. So you see, malware attack was successfully executed via Microsoft Word document, which is correct. The attack employed living of the land technique, binary masquerading, DLL loading. Okay. So let's see. Technical analysis. This is the initial vector. Attacker began when they opened the Word document d.doc. Okay. That is correct. And then it is showing you different phases. Initial execution is opening the d.doc. Second is command execution, where command.txt was executed by WinWord. Okay. And notice it also detected that obfuscation technique, which is the variable substitution. Remember? Okay, it automatically detected that this is substituted to this guy, substituted.txt, and then it is masquerading it as curl.txt. Okay, as you can see, it automatically detected that as well. And then it's telling that curl was used to perform a DNS resolution and download this PHP, drop it to disk. Okay, so whatever we did manual. And the payload, how it executes this payload is using registrar32.txt to load the DLL. Is it okay? Fine. And also, yeah, it detected all the indicators and so on. And also the MITRE mapping. Yeah, and then recommendation, etc., etc. Okay. So if you open the dot file, this is what it is. d.doc is opened by WinWord, command.txt copied and renamed certutil as curl, made a DNS query, downloaded it, again same thing, it invoked registrar32.txt to load a DNS. Is it okay? Fine. So with that, I've almost come to the end. Just be with me 2 more minutes. The key takeaways is that the cyber threat landscape is constantly evolving, and AI hunting can help you with detecting complex attack patterns. As you can see, if you give proper context to the AI, it can help you detect complex attacks. There was a few other demos as well. It was more related to code injection and so on. But anyway, maybe next time sometime we'll take it. So this is what about the takeaway, and this is the part where I do shameless marketing about my upcoming training. So we are, for the first time, we are doing in Black Hat India. Okay, so in case if you are interested in learning malware analysis or threat hunting, we are covering malware analysis, memory forensics, threat hunting in a 2-day course. Okay. If you are interested, you can register. Anyway, we are also conducting at Black Hat USA and DEFCON as well, but I think this is relevant for you guys. Okay, and in addition to that, okay, like I said, we also run a community, Sysinfo. We have our next meet on July 18th. Okay, in case if you are already part of Sysinfo, it's fine. If you want to join the group, this is the QR code if you wish to join the Sysinfo community group where we announce the upcoming meets. Anyway, the upcoming meet is on July 18th. So where I will talk about AI malware analysis. Okay, so I'm working on a tool to perform malware analysis. I'm also integrating some reverse engineering components and so on. So I'm excited to present that research. Hopefully by July 8th, I'll be able to finish that. Okay. So with that, I've come to the end of the session. In case if you have any question, I think 1 hour exact, I think almost. So if you have any questions, is it the time or?
Two questions you can ask. Later you can, after the networking break, you can take it up. Yeah.
Okay, so if you have any questions, yeah.
I had one question that when you're using AI for threat hunting mainly, how did you how reliable is it and how?
So my question